Lesson 5.7, completing the square. This is part 1 of the process. Then we'll have part 2 later. What is completing the square? Think about completing something as finishing something. It's going to be another method that we can use to help us solve a quadratic equation to find its roots. Remember, those are also called solutions. They're also called the x-intercepts. So really in our toolkit, we should know that we can graph a quadratic to find its x-intercepts. We can actually factor it, even though it's not in this unit, but we factor it and set the factors equal to 0 and solve them separately. That only works when the numbers are nice, no decimals, right? Or no, like, irrational numbers, I should say. Now I can't even say that. No weird answers, you get what I'm saying. We can, what do we just do? Oh, quadratic formula, duh. Quadratic formula, and then now is just another one. But I will tell you, I don't use this process a whole lot, but I do kind of enjoy it. To complete the square, we first have to talk about perfect square trinomials. So let's say I want you to factor this guy, x squared plus 8x plus 16. That's just a basic trinomial. So it's saying this would be x times x. What two numbers multiply to make 16 that add to make 8? That would be a 4 and a 4. So since they're the same factors, that's called a perfect square trinomial. What about this one? What two numbers multiply to make positive 9 that add to make negative 6? Well, those would have to be two negatives, and it'd be negative 3 and negative 3. So even if you don't have a perfect square trinomial, you can always make one. The way to do that is to take the b value divided by 2 and square it. So if I said what number needed to go into this blank to make this a perfect square trinomial, this is your b. So you take negative 10, you divide it by 2, which is negative 5, and then you square that number. That'd be 25. And so now this could be factored into x minus 5 times x minus 5. See how that would get that trinomial? Kind of cool. This one, same process. Take your b, divided by 2. 12 divided by 2 is 6. 6 squared. Our magic number is 36. And that would factor into x plus 6 times x plus 6, or you could say that quantity squared, or that factor times itself. So I call that the magic number. Some questions will just ask you to find the number that would have to be added to complete the square. So right now I could not factor this. There's not two numbers that are going to multiply to make 13 that are going to add or subtract to make 4. So what you need to do is keep your a and your b. I want you to put plus blank equals, we're going to subtract or move the 13 over, and then you want to put plus blank. So that's the process. Your a and your b stay on the left, plus blank equal your c moves to the other side, plus a blank. In an equation, what I do to one side, I have to do to the other. So right now, I'm going to take this b, divide it by 2, negative 4 divided by 2 is negative 2, and square it. So that would be 4. And I would put this here, but they're not even wanting it that far. What's the magic number? 4. Okay, in this problem, so really I could just look here. I don't have to move it, but I'll take my b of 13 divided by 2. Doesn't simplify, doesn't divide. I'll square it. When I square a fraction, it's saying this is times itself. It's going to be a 13 times a 13, or a 13 squared, which is 169. 2 squared is 4. So that would be the magic number. Okay, so now let's take it a step further, and this intermediate step is not finishing it, but at least getting it to the middle part of this process, and then we'll finish it on the next lesson. We want it to be something squared equals b. Okay, so what I want is my x squared. I'm going to add 10x. I'm going to put plus blank equals. I'm going to move my minus 39 to be positive, plus blank. I'm going to take my b, divide it by 2, and square it. So my magic number is 25. Now what I should be doing is factoring this trinomial. It should be a perfect square trinomial. So this would be an x times x, 5 times 5. And that would make your 10x in the middle. Or how we could write this is x plus 5, that amount squared. Okay, and then I need to simplify this side by taking 39 plus 25, which would be 64. That's how it wants. See how it matches this template of something in parentheses, some factor squared equals a number. That's all they're wanting you to do. right, let's try another one. We've got x squared stays, the b, the negative 14x stays, plus blank equals, I have to subtract this 118. 5 minus 118 is negative 113. And then I'm going to take my b, divide by 2, square it, becomes positive 49. You have to add that on both sides to keep your equation balanced. I should be able to now factor this. So I'm going to go ahead and write it's something squared. So what two numbers times themselves make 49 that add to make negative 14, negative 7 and negative 7. Negative 113 plus 49, I don't know, negative 64. And that's as far as you would have to go. Number 7, I'm going to have to subtract 9x over. And that'd be 14x. And then add the 19 over. Plus blank equals 19 minus 4 is 15 plus blank. So you'll get really good at noticing 14 divided by 2. You get good at finding it fast. 7 squared is 49. Okay, so this would be x plus 7, that quantity squared, equals 64. Why do we have so many 64s? Okay, last one, why don't you try it on your own real quick? And that should be your final answer.